Hey everyone, this is Jillian, and now we're going to take a look at truly translating math into English and English into math. So, we've talked about this already and how math is a language, and just like if you learn French and English at school, you know that bonjour is hello and hello is bonjour. Pardon my accent if it's not excellent. And the same goes for math. And the more you really understand that this is a language that you just need to learn how to translate and then you can just go with it, the easier it's going to be on you, the less frustration you're going to have, and the more you're going to really shine and run with understanding. Obviously, in math class, there's nothing better than learning something and just totally understanding what the person explaining it to you has to say, and then being able to duplicate that and demonstrate that you really understand without much thinking. You just see something and you know what to do next, and you know what to do next. So just keep on keeping on. It's really, really important that you do not quit practicing and that you really do a little bit every day so that you can move toward really being excellent at speaking math, so to speak. So, all of that said, let's take a look before we get into some word problems using solving linear systems like with methods like elimination and substitution. Let's just take a look at translating. So, for example, the steps are, first we're going to express the situation in words that we are given into an equation with two variables. Now, you likely will probably want to use X and Y, but you might find if you have something with nickels and something with dimes that you let N be the number of nickels and D be the number of dimes, and then it's really obvious what's N and what's D. You're also going to want to determine how the unknowns are related. This is super key. And you'll be able to determine how they're related because you'll be given that information, and then, or it's something that's already obvious to you that you know, and then you're going to write an equation that shows the relationship between the unknowns. So for example, Mitch invested a certain amount of money, we don't know what, at 9% per annum, and another amount at 7.5% per annum. Write an algebraic expression for each situation. So the total amount of money Mitch invested. So he invested M amount at 9% and N amount at 7.5%, and that is the total. The total is the amount invested at M and the amount invested at N. And we know that these are the amounts because it says here that he invested this much money and then this much money. The interest, something to really highlight here, the difference between money invested and interest is something like this. Just don't even look at this and just think for a second. You have $100 at the bank. You put it into the bank account, your bank account. And let's say you're really fortunate in today's day and age and you get 1% per annum on your money. Well, you know that 1% of 100 is 1. So that means at the end of the year, you will have $101. You will have your $100 you invested, put in the bank, the $1 interest for a total of $101. So really, really make sure that you understand what I just said, and now we're going to move on. So the interest he earned, the interest that he earns at 7.5% in 1 year is, like we just did 100% of, 1% of $100. So here we're going to do 7.5% of the amount of invested at 7.9%, 7.5%, which is N. So that's English, and then in math we do 0.075 when we turn a percent into a decimal, times of always means times N. So you're used to seeing cleaner numbers like 3x and 4y. This is 0.075 N. And then the total interest Mitch earned in 1 year is, of course, the amount he earned on the investment of 7.5%, and means plus in math, and the amount that he earned at 0.09, which is this, which is the total interest. Okay, let's take a look at another one.